So there are natural sources from land, but also there are land use changes. So slight distinction in terms of human perturbations enhancing carbon emissions from land, biosphere, and land in general. So these are the recent estimates of emission from land use change compared to the IPCC estimated mean and range. So here are the IPCC mean and range shown for the 1980s and the 1990s. And again, the point is that various estimates done by different methods and different approaches that rely on data. When you go back, so this is in carbon emissions per gram carbon per year. Again, you can see the range here. The main point is that this shows somewhat of a decrease, but the range of in the differences is much larger when you go before about 1970, because the data becomes sparse and models are not well constrained, etc. So the good news is that as you come forward into the current periods, the uncertainty between different estimates begin to drop off, and there is a apparent decrease in the emission from land use, which was somewhat evident when we looked at the emissions overall from land use. Okay. Let's look a little bit more into the carbon sinks and sources across the continents. So these are regions of the world, other, where there is no data available, tropical regions, temperate regions, and boreal forest regions. This is looking at different periods, so forest carbon flux for the 90s and the 2000s. So this is from the book, so the period is restricted to 2007. Again, looking at gigaton carbon per year from world forests. The same as before, when it's pointing up, it's a source, and when it's pointing down, it's a sink. So you can see the colors favorable for greenness is sink. So you can see North America, small sink. Canada, almost flat there, very small numbers. Sinks. So sorry, let's see, make sure. This is carbon fluxes. This is tropical regrowth carbon flux. Tropical for 2 decades. Tropical gross deforestation carbon emission for the 2 decades. So please be careful with the color coding. So they're trying to distinguish the boreal and temperate forests from tropical forests and tropical deforestation. Again, these are estimates, and one has to be always careful. So here, downward facing direction represents carbon sinks, whereas bars in the upward facing direction represent carbon sources. Light and dark purple, global established forests as boreal, temperate, and intact tropical forests. Light and dark green correspond to tropical regrowth with forests after anthropogenic disturbances. So details there. So there was, let's say, some disturbance, conversion to agriculture, and then abandoned and regrown, or as a part of the afforestation effort, like over India and China and so on. And there are tropical gross deforestation emissions as well shown here. So this is again mixed news. If you want to think about mitigation efforts, you have to consider where the deforestation and perturbations or disturbances are the largest, and what are the potential there for stopping deforestation, stopping disturbances, and letting the forest recover and then become additional sinks. Okay. This is a table showing global carbon budget in petagram carbon per year. This is from the IPCC 4th assessment report, and there is a global carbon project that is run under UNESCO, I think. It's talking about emissions, atmospheric increase, ocean atmosphere flux, land atmosphere flux, and they are partitioned as land use change flux and residual terrestrial flux. So as we saw in that map showing the fossil fuel, land use, ocean uptake, land uptake, and so on. there is a residual flux that's not balanced. Some people call it missing sink, but this one calls it residual terrestrial sink, arguing that there is no missing sink, that it is actually going in the land biosphere. But it's not clearly accounted for in terms of identifying where it's going. Okay, so you can see that the total emissions have gone up in both estimates. This is for 2000 to 2005, 90s, and 2000 to 2009. So various estimates. Atmospheric increase, obviously. Ocean atmosphere flux is negative and it has increased, so ocean uptake continue to increase, but the argument is that the rate of increase of uptake by the ocean is decreasing. So ocean may be slowing down as a sink, which is understandable in terms of warming, circulation changes, etc. Land atmosphere flux, you can see it's a negative as well. So land continues to be an increasing sink. Land use change flux increased, but then maybe not increasing or remaining steady, but you can also see the uncertainties are quite high. The terrestrial residual sink is higher, so the missing sink or the potentially uptake by the land biosphere is gone up. Okay. The other things to add to this, peatlands, obviously more in the colder climates where the respiration rates go down because of the cold temperatures. So those basically carbon-rich soils, peatlands. But there are also large peatlands in low latitude, especially in the maritime continents, in Africa and South America and so on. These are known sources, and the emissions from peatlands by country estimated is shown here in terms of million tons CO2 equivalent. If you remember, there is polar amplification of global warming, so warming rates are much higher at high latitudes, which corresponds to these increased loss of carbon from peatlands, and there is also a hot spot here. This is largely due to human perturbations, but also this is a hotspot for ocean warming as well. Okay, ocean dynamics and the atmospheric dynamics together are such that there is massive amount of rain here as well as massive amount of warming. Plus there is lots of human activity as well. Okay, just keep those things in mind. Again, any place where there is loss of carbon from land is going to be a potential region for mitigation target as well. Forest fires, there is no clear evidence that forest fires are increasing. There are natural occurrences of wildfires, but there is some evidence that the intensity and duration of the forest fires are increasing. That's a complicated story, but this is a composite map from satellite data from MODIS, Moderate Resolution Imaging Spectroradiometer, and it's over several years to produce this, let's say, a climatology of forest wildfires. And if you look at the emissions of carbon from fires going from 97, you can see there is no clear trend, but there are years when you have had massive fires like the Australian fires in 2019, which emitted 1,000 million metric tons or 1 billion metric tons, which stood out compared to all the years on this record. Okay, and this included one of the strongest El Niños, and this was also a very strong El Niño in 2015 and 16. Usually during El Niño you have droughts and forest fires, and sometimes human beings setting intentional fires when an El Niño forecast comes to clear out land for palm oil or development and so on. And the Australian wildfire was much, much larger than that. So that's bad news. Okay, so we'll come back and look at the mitigation potential in different sectors. Okay, so we are just tracking feedbacks, emissions, and then we're going to come to mitigation potentials.